Hey everyone, welcome back to Aseens. So in today's video we will be talking about homologous series and chemical properties of carbon compounds. So let's get started. So what do we mean by homologous series? Okay, so when we are talking about homologous series, we need to select a family from our carbon compounds. Like for example, we have got alkanes, we have got alkenes, alkynes. Then over there we have also got families with the functional groups, that is alcohol, aldehydes, ketones, carboxylic acid, so and so on. So we need to select a particular family and we need to select two consecutive members. This is very important. Like for example, if you are selecting an alkane, I can take methane, ethane, or ethane, propane, propane, butane. So any two which are consecutive, that means which comes one after the other. You cannot take methane with propane because they are not consecutive. We have got ethane in between. So we need something which is continuous. Okay, so we need to take two consecutive members, any members. Okay, it can be further at the a very large ones, or they can be the smaller initial ones. Okay, it does not matter, but we need two consecutive members from the same family, and when you subtract them, if you get a difference of CH2, then we call the particular series as homologous series. So basically all our families are homologous in nature. Okay, so sometimes the question arises where you have to prove that they are homologous. Okay, so I'll show you how. Like for example, if I select alcohol and if I select the two members to be ethanol, that is C2H5OH, and after this comes propanol. Okay, I'll take propanol, so it's going to be C3H7OH. Okay, so now if I subtract them, OH gets cancelled. 7 minus 5 is 2, 3 minus 2 is 1. So I have got CH2. Similarly, you can try with your alkanes, alkenes, alkynes. You can try with all the families. Take any two consecutive numbers. The bigger one should be up and the smaller one should be below as your normal subtraction rule. And when you subtract them, if you are getting, obviously you are supposed to get, if you are getting CH2, that means the series is homologous. Now, what are the benefits of this homologous series? Okay, according to the homologous series, as you go on, as the molecular mass rises, as you go on, in the higher values of the members, what happens is the molecular mass goes on increasing. Because of that, the melting points and boiling points will increase. Other than that, it will show differences in their solubility test as well. Carbon and its compounds, they do not dissolve in normal water. They get dissolved in carbon solvents itself. Okay, we did not go in detail with it. So just the basic ones is that their solubility, all the physical properties, whatever they have, as they go on, as the molecular mass goes on increasing, they are going to show a little difference in their physical properties as well. Okay, so that's about your homologous series. Next, we are going to talk about chemical properties. So what chemical, we have got 4 over here. Okay, one by one we are going to see. The first one is combustion. So this is a very common term which you get to hear very normally. So what do you actually mean by combustion? When you burn something in the presence of oxygen with the intention of harnessing the energy, then we call it as combustion. You are burning something in the presence of oxygen for fuel purpose, then we call it as combustion. So normally for combustion purpose, we select the fuel which is actually rich in carbon. The reason behind this is when you burn carbon compounds or anything related to carbon, it releases large amount of heat and light, and that is the reason why carbon is preferred for combustion. Okay, so we have got 3 examples over here. This is from your textbook. So normal carbon, that it can be your coal or anything. Okay, the purest form of carbon. When you burn in the presence of oxygen, it's going to result in carbon dioxide along with heat and light energy. So this is what we need. This is what we are using for our energy purpose. This all are byproducts. Okay, this is what our intention is for combustion. You burn it for this. Okay, then comes methane, CH4. Methane, when you burn in the presence of oxygen, again you are going to get carbon dioxide along with water and heat and light energy. So carbon dioxide and water are the byproducts. That means which we don't want, but because of the reaction they are forming. Okay, they are left aside. Then comes alcohol. Okay, C2H5OH. This is ethanol. When you burn in the presence of oxygen, once again you are going to get carbon dioxide, water and heat and light energy. So this is what we'll be harnessing. Now, before moving forward, there are two types of flames which you will be observing. There are flames where you will see blue flame with no soot. You won't see any black color vapor like thing rising. Okay, as you can see on the screen. Okay, so such kind of flame is caused when you're burning a saturated hydrocarbon. A saturated hydrocarbon will combust completely. They'll be burning every inch of it and they won't cause any wastage or pollution. In such cases, you are going to get a bluish flame, bluish non-sooty flame. Okay, soot will not come. The black color vapor which you get while burning, it won't be appearing in case of saturated hydrocarbons. In case of unsaturated hydrocarbons, you are going to get a yellowish flame. Okay, for saturated, you're going to get a bluish flame. Okay, non-sooty. Whereas for unsaturated, you're going to get a yellowish sooty flame. Okay, as you can see here on the screen again. So yellow color sooty flame will appear. Okay, and if that is the case, it's actually an indication that combustion is not complete. Whatever fuel you have given, it is not completely combusted, it's not completely burned enough to actually pull out all the necessary energy we can. So that is the case, okay, of the different colored flames. So that was about combustion. Next we are going to go for oxidation. A normal understanding of oxidation is that when gaining oxygen, in a reaction, if gain of oxygen happens, we call it as oxidation. So in short, oxygen is taken or oxygen is added. In a reaction, when oxygen is being added or gained, we call it as oxidation. So here we are taking a simple example of, this is a general part what I have done. Alcohol is converted into carboxylic acid in the presence of either alkaline KMnO4, either this, or acidified potassium dichromate. Okay, so either this or this, any one. These two are the catalysts. So catalyst is something which is helping the reaction to occur. Moreover, this also act as the oxidizing agent. They are the ones which are giving the oxygen. Okay, as you can see here in the reaction, we have taken example as ethanol, C2H5OH, and you can see here on the other end we have got ethanoic acid, carboxylic acid, 2 carbons, hence eth. Since it's a carboxylic acid, it is ethanoic acid. Now if you observe, just count whatever we have got 2 carbons here, here we have got 2 carbons, here we have got 3, 5, 6, right, 6 hydrogens, in this case 3, 4 hydrogens, so 2 hydrogens are missing here, 1 oxygen, here we have got 2 oxygens. Now the point comes, from our reactant to our product, we have got 1 oxygen extra. From where does this oxygen come? It comes from either this or this. Okay, whichever you have selected, this one is also capable of giving oxygen, this one is also capable of giving oxygen. It depends upon you which one you are selecting. So now when you react, when this reacts in the presence of this, okay, what happens is an oxygen is gained over here. So as you can see in the structural formula, see here, this 2 hydrogen is going on missing. So this 2 hands, when these 2 hydrogens are removed, this 2 hands are free. So these 2 hands will join together for 1 oxygen. Okay, so now these 2 hydrogens will be left aside. Okay, so that is how, since oxygen is being added in this case, always remember in case of oxidation, alcohol is being converted into carboxylic acid in case of carbon and its compound. So the question, your exam question papers, they twist and they ask. So they might ask you what happens in an oxidation reaction, or which particular carbon compound is converted into which particular carbon compound. So alcohol is converted into carboxylic acid. They can ask you about the oxidizing agents. Okay, so that's what you need to remember here. Next comes addition reaction. Okay, so addition here refers to addition of hydrogen. So you are giving hydrogen, then we call the reaction as addition reaction. If you are giving oxygen, we call it as oxidation reaction. So if you see here, in the case of oxidation, we have given oxygen but removed hydrogen, but we didn't take that into account. Since we were adding oxygen, we called it oxidation. Similarly, when you are adding hydrogen, we call it as addition reaction. So addition reaction is taken place, it is brought into existence for unsaturated hydrocarbons, that is the hydrocarbons with double and triple bonds. So you have selected one over here. As you can see here, don't get confused with the R's over here. Okay, this R stands for your alkyl group. That means in this place of R, you can have hydrogens or you can have another carbon stuff. Okay, so CH3 or something. Okay, so that is how they are actually keeping it, because this is like a general formula. You can use it for anything. See, if you are getting confused with this, you can select any one particular alkene or alkyne over here. So now this hydrocarbon, okay, unsaturated hydrocarbon and hydrogen. Okay, so hydrogen is what we need. We need to add this hydrogen, right? So hydrogen gas along with alkene, okay, any unsaturated hydrocarbon, in the presence of nickel catalyst. So this nickel is helping to actually increase the rate of the reaction. So catalyst is something which will either increase the rate of the reaction or decrease. In short, they alter the rate of reaction. Increasing or decreasing, it depends upon what type of catalyst you are using. So in this case, this will help in increasing. Okay, so in the presence of nickel catalyst, when these two reacts together, this double bond will break, and when this double bond breaks here, they will be leaving with 1, 2, 3 hands. So one more hand is needed for both. So that one more hand will go and attach to this hydrogen. So one hydrogen will join here and one hydrogen will join here. So that is how your addition reaction works. And now moving on to the last one, that is substitution reaction. Substitution here refers to changing places. Okay, so this happens in, the best example here is your methane along with chlorine. Normally methane and chlorine, they do not react with one another, but in the presence of sunlight, they do. So what happens in the presence of sunlight, this chlorine, so I have drawn the structural formula below so that it becomes easier for you to understand. You can see a methane, this is our chlorine, 2 chlorines, right? So now in the presence of sunlight, what happens is this bond is broken between chlorine molecule, and because of that, this chlorine atoms will be free, these chlorine ions will be free. And now what happens is, with this free chlorine ions will go and react with the methane. It will target one particular hydrogen and they'll substitute. That means this chlorine will take the place of that hydrogen and force this hydrogen in the place of it. So what happens is, instead of this hydrogen, we'll be left with the chlorine over there, and this hydrogen which actually left the methane molecule, it's going to combine with the other chlorine and it's going to form your HCl. Now, the reaction does not stop here. What happens is, furthermore, as the chlorines are being, broken down, they are going to target the other hydrogen molecules, and it will result in, see here, you have got your CH3Cl, then you're going to get CH2Cl2, and then it's going to be CHCl3, and lastly CCl4. So this will be the last one. Okay, so till all the hydrogens are separated and replaced, substituted by chlorine, this chain will go on continuing, and finally when all the hydrogens are replaced by chlorine, they are going to leave it aside. So that is how your substitution reaction occurs. Okay, so in case of doubt, you can just leave me a comment at the bottom and I'll get back to you as soon as possible. Thank you.